tell us about the update of Eclipse Chariott.
Yeah, so before I start, for everyone that is online and just joined, my name is Filipe. I'm a program manager on the Azure Mobility. With me, I have Patrick. So go ahead, introduce yourself.
I'm a dev manager at Microsoft, working on this particular project with my team.
Okay, thank you. I know that I'm probably between all of us and a couple of beers and some, you know, and a little bit of time. Just, yeah, indeed. So we want to provide you an update on a first project we contributed 3 months ago, roughly speaking. And if you think about the word debuggy, now you can try to listen me saying democratizing the in-vehicle application development. And this is really the objective of Chariott. We want to simplify, as we have mentioned before during the presentation of debuggy, we want to really simplify app running inside the vehicle, abstracting as much as possible the vehicle complexity. And we do this through the introduction of a concept which we call capability-oriented architecture, capability-oriented model for application to application, but also application to the digital twin representation of the vehicle itself. In the last episode, when we brought the first demo, which is publicly online on YouTube, and you can watch the recording, we brought the concept of dog mode. Yeah, trademark Tesla, whatever we need to say here on the call now, so that it can be recorded anyway. So we brought the concept of the dog mode as an application in the vehicle, which would use the programming model and the vehicle signals to activate the necessary conditions in the car, the temperature, the windows, so that the dog feels safe and healthy. So to this episode, we went a little bit further ahead. We brought the car and we brought the dog. And this is what I'm going to ask Patrick to lead us now with the dog and now with the car. Patrick?
Can you operate this thing for me? Is the video running? So we can see the dog, actually. All right, perfect. So last time we did present this, and if you look at the UI, it almost looks the same, and you might ask yourself, did the guys only work on draining the battery to 14% and adding a couple of images of a dog? No, that's just the what you're seeing on the UI, but we actually invested quite a bit of time to make sure that we can enable application-to-application communication besides only in quotes, going down to the car, executing some functions and get feedback back through telemetry information. We did this, as Filipe mentioned, is we added what we call capability-oriented architecture. So everything around Chariott is becoming is participating in that model where they are applications providing capabilities and their applications consuming those. We did use a dog mode scenario for defining a couple of what we call intents, like discover, inspect, read, write, or subscribe is one, and invoke. So those are intents that applications can request from Chariott, and they are being brokered to applications being able to fulfill those. And that's kind of the basic model that we're using. We're totally expecting this list of intents to grow as we actually expand on different scenarios, but this is what we have right now for supporting the dog mode scenario. Previously, things were slightly more static than what we have right now. We didn't have you did actually have to know what's available in the car to you. Right now, we changed this, so we have what we call two intents for discovery and for inspection of the car. So you can, at runtime, go query the Chariott runtime and figure out, okay, what capabilities are available to me and what's available in the car to me, and adjust your application at runtime. So that gives you the ability, for example, here the dog mode scenario, to check is there a camera I can use for the in-cabin stream, and is there any component that can provide object detection, and if so, you can enable and light up that feature. If not, you can simply run the same logic and only turn on the dog mode through the UI. So this is showcasing a bit on how you can dynamically adjust your application to what you have available in the car. One thing that we kept the same is, we actually kept quite a bit of the same, but one thing that we're building on top of is the Grpc API. So it's a pure Grpc API. You don't need to have any SDKs for starting to work with Chariott. You simply have to have support for generating the Grpc stubs, and then you're good to go, and you can work with any programming language that supports it. Last but not least, we have expanded a bit on the broker. So the broker is capable now of brokering requests for intents between multiple providers. One scenario that we looked at there is cloud support. So the object detection is an application. It's provided as a capability to our dog mode application, and it can either run local with a TensorFlow model, or it can actually run in the cloud. That's just an experimental feature that we're looking at. Happy to get feedback on it. We know that there are quite a bit of challenges of doing these sort of splits, but we found it interesting to actually invite the community in and start a discussion on this. With that, we're going to start a short video of 40 minutes. I'm kidding, it's just 8 minutes. But there's going to be a longer version, actually, of the video, which is a 20 minutes video which shows everything. The video that we're going to show is only going to show the basics of the model and how it works together. And if you're interested in the longer video version, I think we're going to post it up on the same channel, and you can have a look at that.
Okay, so in this demo, what we're going to see is the application programming model in action. We're going to get connected to how the dog mode application is actually talking to Chariott and all the various capability providers. So just to give you an idea of what all is running over here, we have the different applications such as the simulated camera over here providing the camera feed. We have Chariott running as well, the vehicle abstraction service, which provides the capabilities for various capabilities for the digital twin. And we have the object detection and the dog mode logic. These applications, their source code is coming from the examples folder over here. So you can see there's more processes running obviously over here, but these are the basic sets of applications. And I'll be showing you how the registration happens next. So we're just going to go and pop open the vehicle abstraction service and see that as soon as it starts up, one of the first things it does is that it goes ahead and registers itself with Chariott. It says that it's providing these various intents for the vehicle digital twin. So that's the VDT over here, and that's the endpoint at which it can be reached. So this is the endpoint that Chariott uses to connect to the VAS. And then these are the various intents it can fulfill, such as, invoking commands, inspecting the digital twin itself, subscribing for events, and also being able to do point reads, as well as discovery of other services, and we'll look at that later on. Okay, so let's go ahead and look at what this looks like from Chariott's perspective. So one of the things I'm going to do over here is I'm going to interactively talk to Chariott through a bash script, and this bash script is basically a nice helper around and a wrapper around grpc curl. So we're going to be sending grpc messages in a very simple way through subcommands. So one of the subcommands is inspect, which represents the inspect intent, and we're going to go to the system registry. This is a capability that is offered by Chariott itself, and we're going to go ahead and ask for everything in there. That's what the double star stands for. And we can see over here, for example, that there is the digital twin that is registered, and exactly what you saw with the main entry point. These are all the various intents that it can fulfill. The same thing is for the dog detection. You can see that the simulated camera is also registered, and then we have a key value store as well. All right, so returning to the digital twin, one of the interesting things we can do is that we can see that there's the SDV VDT. So we can take the same intent and ask it to be fulfilled against the digital twin. And so what's going to happen over here is that the Chariott is going to receive the inspection intent for the digital twin, and it's going to broker that over to the VAS because it knows it has registered to offer that capability. And so what we see over here now is a different response coming back. So we see that it is telling us about the digital twin itself, such as that you can get the temperature. It is a property. You can read that property. It has a type of int32, and it can be watched. And this is exactly what the dog mode application is doing up over here, is that it's going ahead and starting up and inspecting the digital twin for what all capabilities it offers, as well as if there's, for example, the camera feed and dog detection available, then it's lighting up certain features. So you can see again over here, there's a battery level. We have also the aircon state. The aircon state is a property that it happens to be of type Boolean. And then we have finally a command that can be issued, and that's what the dog mode application does, is use that command to activate the aircon. What I'm going to do next over here, I'm going to take the temperature, and I'm going to show you that instead of the inspect that we have seen now twice, I'm going to go ahead and read that value. So we're going to ask, we're going to issue the read intent over to Chariott. It knows that this is a capability that is being offered by the digital twin, which is being offered by the VAS, and we're going to ask it to read the temperature. And you'll see 25 degrees. It was just over there. If I keep doing that again and again, you can see it is pretty much how the same temperature that dog mode application is showing up over here. Now, something I just want to very quickly show to you over here, something we have as a helper in the bash script, is be able to see the actual gRPC message that was sent, through Chariott over to the VAS. And you can see that it was for the digital twin. So that's where this piece is going into the gRPC message, and then the key that I was asking to read is going into this key field over here of the read intent. Now, this JSON message that you're looking at, this is just purely for human readability to be able to explore those gRPC messages, but obviously at runtime, they're being shipped over in their native binary format in a super efficient manner. Okay, so I'm also going to show you over here the response that came back from the VAS and Chariott. So you can see that when that got fulfilled, it read a value that was in 3224. So that's what I got last. So hopefully that gives you an idea of the kind of gRPC messages that are being exchanged between the different parties. Okay, so the next thing we're going to look at is the application-to-application communication. And for that, obviously what we want to be able to do is connect to applications without going through Chariott. So discovery is an intent that is also part of the Chariott vocabulary and the programming model. So that what I'm going to do over here next is that I'm going to ask the VDT. You remember that it also offers the discover intent. And we can see over here that we can say discover what all services does the digital twin offer. And you can see that this is an endpoint that is directly for the mock VAS. And over here, we can see that this is the endpoint. That's what it's supporting on that endpoint as an API. And we can see it's a gRPC API for streaming. So in this demo, the events are being streamed directly between applications. So that's what we're going to go ahead and do next, is that we're going to say that we want to listen to the digital twin. Now, what this is going to do is listen is not really an intent. It's going to go ahead and exactly issue the discover intent, find out the endpoint, and the bash script is going to create a direct connection with that endpoint and open up that stream. And then it's going to be between the bash script and the actual mock VAS. And so it's only going through Chariott for the discovery of that. And this is exactly what the dog mode application is doing behind the scenes to read all this temperature data as well as get the camera feed. And so what I'm going to do next over here is open up that channel. We get an identifier. This is not going to be very material over here for our demo. So it's listening. And over here in parallel, what I'm going to do is I'm going to go ahead and ask the bash script to dump everything that's coming over that channel. So we have a simple subcommand over here called events. And right now, there's no events being delivered because the channel is open, and the stream is there, but we haven't actually made any subscription. So you remember that for the temperature, instead of reading it, what I'm going to do next is I'm going to subscribe to the temperature. And at this point, that the intent to subscribe was delivered to the VAS because it is what can fulfill that intent for the digital twin. And at that point, it knows that a stream was opened for receiving those events, and that's what we're seeing coming over here. So the same is for everything else over here, for the camera feed, the battery, the temperature, and all the other aspects. So hopefully that gives you an idea of what all the different parts of the application programming model, how the applications are interacting through Chariott using those various messages. Thank you.
The dog name is Isis. She is a 7-year-old dog with quite a personality, and you cannot imagine the pain that we had to actually record that video that allowed us to build a dog mode competing scenario like what Tesla has been doing, you know. Anyway, so a little bit more serious now. In the first contribution day, we presented the architecture. And the architecture, we talked about the vehicle integration providers, and I've brought a little bit of these from the DTDL concept of the vehicle digital twin. You also see the in-vehicle digital twin part of the same architecture. You see the provider registry and the broker and the capability-oriented architecture model that we are bringing with the concept on this contribution. Last but not least, the dog mode application itself, which, as you might have inferred from the presentation, at the moment uses a TensorFlow application running inside the vehicle and uses a mobile net model, if I remember well. So it's a pretty standard object detection that you can pull up from the internet. And we could definitely use this to a cat mode or some other kind of detection inside the car itself. So we try to generalize this. As Patrick also mentioned, we did an investigation on how the application programming model could actually switch between in-vehicle and the cloud. And in the code and in the long video that we are going to make public, which is a 20-minute, we also highlight how, for example, with the concept of constraints and policies, your application can say to the application programming model, I need to do this dog mode detection, but if I don't get a response within 10 milliseconds or 1 second, the provider itself with the application programming model can make a decision on a policy to run the call in the cloud or in the vehicle itself. So essentially, we abstract the concept of the capability itself. And so this is a little bit of what this diagram is all about. So the dog mode today is a UI and some logic that exists. So you consider it as an in-vehicle application that you bring to the car as a service. We have the in-vehicle digital twin that you saw from us presenting a little bit of the concepts. And again, it is concepts, it's not a project even, it's for the community, for us to, and I think we have used the word collaborate hundreds of times during the day, but it's really about that collaboration that we want to bring to the community. The dog mode detector, which is that abstraction that you see, again, there are 2 detectors in this demo. There is one running inside the car, one that uses cognitive services from Azure in the cloud itself. Last but not least, the mock implementation, it becomes data. It's abstracted for the in-vehicle digital twin. We are connecting to a feed on the camera stream. We also had an implementation for the simulation of the temperature inside the car itself. And then, of course, Chariott that brings this capability of, I want to discover, I want to look at the vehicle, I want to use those capabilities. How can I actually do this without an SDK? So with that, I have, and I'm going to skip several slides that explains these that are available in the public version. They guide you through everything that you saw through the demo. And I would just want to bring a little bit of the key takeaways. Just bear with me. There is a slight delay. Okay, it's almost there, almost there, almost there, almost there. There. Yeah. So, Those slides that you have seen explains the flow of the demo. The code is code available for you to take, and again, it's code for you to build upon. What we would like from, if there is an ask that I could do to the community, is use the code, test it, and then, tell us how that works and what features we need to move on. So what you have seen, a remote-based API, so based on Grpc, there is no SDK or no batteries included, as we could say it. It has these common operations or intents to inspect the car, discover if there is a capability, and then read and write. You have seen this brokering system that allows you to, as soon as you discover those, make the applications talk to each other application. You have not seen in the demo, there is a key value store implemented that allows us, for example, to exchange state between the applications. Is it a key value store that you need to use? No, not at all. It's just the concept. Bring your own optimized key value store to the broker itself. We have the dynamic discovery, and I think through this process of the integration with the vehicle digital twin and the intents, we have the inspection of the system, again, looking up how the applications use these. And then last but not the least, we did a substantial effort on the integration with the in-vehicle digital twin. And so with these, I'm going to close the presentation. Really, the key takeaways and the next steps from us is really to go into the community instead of us just bringing yet another more features. There is a very detailed 20-minute recording of this demo, and I would say recorded not in a 1.5 accelerated modes. And with that, I want to also thank you, Patrick and all his team, because they have been the developers together. Again, Daniel is also here, that they have been the developers coding all of these for us to bring to the community itself. And with that, I'm closing. Open for questions. No, does not run in the car yet. No, it's not production ready yet, but we would love to work with the community to see what it takes for us to make it production ready, so that we make a business out of this, right? And you make a business out of this. And with that, closing for other questions that you might have. Thank you.
Yeah. Questions?
Maybe I can nevertheless ask a different question. So I'm not really sure if I understood it correctly. Let me make an example, and you simply say if my assumption is correct. So I have two containers in which I have two processes running. Can I use this technology for them to interact with each other? Is that the idea?
Yeah, it doesn't. Actually, wherever you run it, this is not really defined here.
Yeah.
It's only a programming model.
Yeah, but for example, if I had this scenario, that would be a suitable technology for them.
We're testing this in a containerized environment.
Okay.
Yeah, absolutely.
Thank you.
And congratulations, you just unlocked the Master of Questions badge.
Okay.
Do you run it as a container? Do you run it as a process? Do you run it as a, and I'm going to throw a keyword to the audience, is it going to become a WebAssembly in the future? I don't think we know the answers now, but this community, I think, is the right place for us to try all those ideas. Yes, we do have a containerized version. The Docker file is there for you to build it. It's part of the pipeline, right? But you can also run it as a process. Now, as long as you have a Rust compiler, it should run as a native process. The communication, yeah?
A second, so a technical detail. If I want this to happen, these two applications talking to each other, is there some third process required to run? I didn't really understand it in the picture.
Chariott.
So Chariott is a daemon, something like?
Exactly. So
okay.
Or think about it, a registry and a broker.
Yeah, it reminded me of what we usually, back in the days, called an object request broker. Is that a fair assumption to say that it serves a similar purpose?
Well, yeah, I mean, it's basically just, waiting for all applications that want to offer something, register, tell where to reach, right? What intents it offers,
and then
for what
namespaces,
right? And then other applications go to Chariott and ask, hey, I want to know, okay, I want to do this. Do you have that? Where can I talk to?
Yeah. Okay. Thanks.
Okay. Any other questions? Online, offline? Patrick, Filipe, great to have you here.
Yeah, thank you.
Thank you.
Yeah.
And let's talk later on at the beer.
Yes, thank you very much.
Thanks a lot.
There is another question.
There's one. Sorry. Yeah, go ahead. No, we have time.
I was already prepared to do it while the beginning the question, but maybe a quick question. When I was looking for the code, where do I find it? Because an Eclipse Chariott repository was empty, so...
Yeah, it's not yet. So we are going to make it public. We, as you know, Microsoft has a lot of processes for us to follow to make open source and make it the code public. We are just finalizing that and should be ready, you know, in I'll say very short. In any case, given this is a community, I'm very happy to share the code whenever there is an ask. Okay?
Okay, good to know. Thanks.